Hello, everybody. My name is Serafeim Vlastos. I'm the VP of Technology of US Projects in Intralot. Intralot is a technology provider of integrated systems to lottery operators, and it is actively supporting responsible gaming. Today's talk is going to be about digitalization of lottery, of retail on lottery industry. Now, I will start by presenting what is the challenge we are facing. So most state lotteries, and that is especially reality in the US market, they operate within a very strict regulatory framework. That framework can impose challenges while we try to introduce new technology and new approaches and experiences to the players. In that environment, we do have a new generation coming in the market as potential customers, which are used to a different experience from the traditional customers that we have in that market. In a few words, they expect everything to be on their mobile apps. The regulation, on the other hand, does not allow it. So we have, as a technology provider, to cover that gap. And in reality, the most important thing that we have to take care about is meet player expectation, but also introduce new technologies on the market for our customers and the players. So right now, we are on the left-hand side. This is a traditional lottery. Paper, cash, a lot of visits to the retailer. And since the regulations do not allow us to actually have a full digital experience, we're trying to do this transition by offering a physical and digital experience to the customers. Clearly, on the jurisdictions that we do have the ability to have full digital experience, we offer it. But now we're discussing about a case that we can offer the solution, however, the jurisdiction and the regulation does not allow us to do it. So we have to be somewhere in between, try to cover the gap and try to prepare the traditional customers to be ready for the digitalization. On the next slide, I'm going to show you one player journey on how we do that. So just think that this whole journey is visits to the retailer, paying cash, getting the ticket, going back to validate your ticket, getting the cash if you're a winner. So what do we do? Step number one, how do you prepare your ticket? You download the app. You prepare your replay slip on the app. Then you have to visit the store in order for the device to connect to a beacon installed on the store of the retailer. And that is done in order to identify that you are in the vicinity of the store and allow you to perform your wagering and the next steps. So once you do that, you can submit your wager, you can get your ticket, you pay with your wallet, and when the draw occurs, the outcome of the draw is going to be sent automatically to your mobile app, to your gaming wallet, and of course, the winnings if you are a winner. So Intralot, in order to support that digitalization, is doing that with the latest solution, which is the LOSX Omni. The LOSX Omni has 4 pillars. Let's start by the first pillar, that is the orchestrator. The orchestrator layer is the entry point to our system, to the core system, and it's responsible to do all the integration either with pre-integrated models or with any third party that we're going to do any kind of integration. The second pillar are the touch points. By touch points, we're referring to the retailer terminals, player terminals, meaning self-service terminals or vending machines. We do have such things, at least on the US market. Instead of going to a vending machine and getting a Coca-Cola, you will get a ticket. The third touch point are the digital interfaces, websites, mobile apps, wherever they are allowed, and digital signage, which are audiovisual content which are used to enhance your experience and your engagement to the games. The third pillar are the enablers. By enablers, we're referring to all the management platforms, and I'm going to give you just some examples. I don't need to go through each one of them. Content management, that controls the UI that is present on all our terminals and the touch points. Retailer management, this is where we control the retailer network. Player management, this is where we control our players. And the fourth pillar is the governance suite. The governance suite offers performance monitoring, auditing, and authentication and authorization. It offers centralized auditing and logging, and also a wide range of dashboards in order to be able to monitor the system, identify issues, and be on top of any potential performance or other kind of issue that may arise. Now, I'm going to dig a bit further to the architecture. That is the architectural blueprint of the solution. And I'm going to focus on two main points. First of all, API gateway. This layer here, that is the orchestration layer that I was referring to previously. This is the gateway to the system. This is where all the integration happens. It exposes a number of REST APIs which will be consumed by either the third parties or the touch points of the player, so terminals, mobile apps, etc. Now, going a step further down, on the core of the system, as you can see here, we have various platforms, but each one of them is not monolithic as most of the current systems are. They are microservice-based, which means that each microservice over there is responsible for a single business. It's completely independent of the rest. It can be scaled up and down independently. So since I mentioned microservices, let's discuss a bit further. Why did we choose microservices and what do we gain from that? First of all, modular architecture. Second, very easy to maintain. What other things do we get from microservices? Independent scaling and also deployments that are seamless to the customer. And whenever we do an architectural decision, we have to focus on what customer needs we're actually covering, and we're taking that decision. So I already stated that microservices are a very good architectural decision because of the independent scaling. Imagine a case that we have a very high jackpot on a game, and we have, of course, very high traffic. It's very common in all markets, in all lottery businesses. So in a system that is monolithic, what do you have to do? How do you handle that? You have to scale up, if possible, everything, all the components of the system. Microservices, we focus only on the game-related processes, the one that has the high traffic. We scale them up. The rest of the system stays as is. When the jackpot is over and the traffic is back to normal, they scale down. Also, deployments. Very typical situation with deployments. You have to contact the customer. You have to tell them, you know what, I have 3 hours downtime. I have to do this deployment. That is a thing of the past. If you do a deployment or an update, you will update specific microservices. The rest of the system should not be impacted. It is not impacted. You have business as usual. You have no loss of sale. You just update a couple of microservices. Whatever service they provided will be down temporarily, but the rest of the system is there. It covers the needs of the customer. Now, orchestrator, going to the second architectural decision. As already stated, the orchestration layer is the gateway to the system, but it also takes care of all the complexities of each transaction. So imagine that there is a request from a third party or a touch point. That needs to be handled by a number of microservices. We don't really want the requester to be aware of that. He just wants to make a request to the system. The orchestration layer is going to do all the orchestration. It's going to make sure that, am I still good? You hear me? Okay? The orchestration layer is going to make sure that it will orchestrate all the transaction and it will complete the flow through all microservices. And once it's completed, it's going to respond back to the requester. So take away all the complexity from whoever is doing a request to a system, handle it internally, and respond back to the requester. One other architectural decision that we made on LOSX Omni is the adapter layer. So it's a very common thing to have a number of third-party integration. That is the reality. We are not experts on all kinds of businesses out there. So in order to offer some functionalities to our customer, we have to work together with third parties. For instance, payment providers. So when you do a third-party integration, you have two choices. You're either going to make the changes in your core business, in your APIs, or since you don't want to change your core business and your core APIs, you put an adapter layer, which is in between your core system and the third party. And I'm going to show you that on the next slide. So we have the integration here. There is a new third party or an existing one that changes their API. We don't really want to change our core service. We put an adapter in between that in a way, does a translation between our API and their API. Any future change is going to happen here. Our core business and our core APIs remains unchanged. Okay, I'm going to move on to talk a bit about security. We offer encryption in transit to all the transactions. We are using TLS 1.2+. Also, all data stored in the database, or in files, or in backups, they are encrypted with AES 256. And all our APIs are secured with OAuth 2 through token-based accesses. We have rate limiting to avoid any kind of abuse on our APIs. And also we do have real-time logging and monitoring to identify any suspicious activity. Performance, scalability, and reliability. It's one of the most important things in any solution that we give to our customer. So let's start with the case that we have a high through-output scenario. Again, this goes back to the previous discussion. It is a very common occurrence in the lottery industry to have high through-output, since every time you have high jackpots, you expect that you have a lot of transactions, a lot of traffic, so your system should actually be able to cope with this. How do we manage that? We offer two options. Both options are in place. One option, of course, is the Kubernetes autoscaler, which is out of the box when you're using Kubernetes, which is something that our system does. It constantly monitors the metrics of each microservice, and if required, it automatically scales up the microservice. When this traffic goes down, it scales it down. On top of that, we also have our own LOSX cluster management system, which you can actually manually scale up a microservice in case that you know that in a week's time or something like that, I expect an increase. So why wait for Kubernetes to do that? I'm going to scale it up right now. Regarding caching, we do have two caching layers. One caching layer is in front of the APIs, and that is used for static content like draw information. We know for a fact that draws do not change, so once it's there, that's it. We keep it there. But also for dynamic but cacheable content like session management, session-related information, we do caching on the in-memory databases. And finally, how do we do perform? We have to monitor the performance of the system at any time and act to optimize it. We use Grafana real-time dashboards to monitor key performance metrics like throughput or latency. We use the ELK stack for centralized logging and analysis. And Prometheus provides metrics collection and alerting whenever an incident happens, what we need to immediately take care of. So, what are the next steps? Of course, we will continue offering additional player journeys to the customers in order to finalize this transition from the current physical experience to a digital experience. We have a high focus on AI, and AI is used, at this point, we use it for customer behavior prediction, AI-driven personalization, operations, and automation, but also we are currently working on an AI chatbot for customer support. And finally, we are working on enhancing our BI solution to provide real-time updates and get actionable insights. Thank you very much. If you have any questions, I'm here to answer them.